lot of you. Okay, Serenity is watching Ken surf. The last 7 times that Serenity watched Ken, he fell twice. I determined the odds in favor of Ken falling this time. So how many times did he fall? Twice. How many times did he not fall? 5 times. Okay, fall off his surfboard. Yeah. Okay, so what's odds in favor of falling? What would it be? 2 to 5. Remember, it's not your totals. We actually have, so this would be odds in favor of falling, odds of not falling. So what's his odds against falling? 5 to 2. 5 to 2. It would never be a total. We're on what page are we on? 23. Jamal, Ethan, and Alberto are competing with 7 other boys to be on their school's cross-country team. All the boys have equal chance of winning the trial race. Determine the probability. Jamal, Ethan, and Alberto will place first, second, and third in any order. Okay, well, whenever we deal with probability, the formula for probability is favorable over total. Number of favorable over the total number of ways we can arrange. So the first thing we want to figure out is how many ways can we make Jamal, Ethan, Alberta come in first, second, and third. These are specific positions, so how can we set them up? We set this up. Spaces. We have first, second, third. Okay? Now we want these 3 specific guys to either be first, second, or third. So how many choices do we have for first? 3. How many for second? You can't have the same guy go first and second. So 2, and then 1. It's a total of how many ways? 6 over how many total ways can we take? How many people are there? 10 people, or 7 boys. Oh, so 10 total, sorry, because there's Jamal, Ethan, and Alberto with 7 other boys, so 10 total people. Now, does order matter here? It does matter, because there's specific positions there, right? Who places first and who places fourth. It doesn't matter which order, like it matters which order they place. So order matters in this situation. So we have 10 total boys, and we want to pick how many? 3, because it's first, second, third. All right, so entering this in our calculator, what's 10 pick 3? Thank you. 6 over 7, 20, which reduces to? Does that reduce? I think it does. Of course it will. They're both even. Open. 1 over 20. Thank you. Because they were going in first, second, third, we wanted them in specific positions. Order did matter. If we were just picking 3 boys randomly, doesn't matter the position, then we'd use choose. Okay? All right. Yeah? Oh, sorry. So we went through that yesterday. So on your calculator, if I was to enter this in, we push 10, and then math, right arrow to probability, and number 2 in this case. So this would be math, probability, and number 3. Okay? Yeah, we did that yesterday. So if you watched yesterday's video as well. Really quick note, we have 1 over 120 here. There's 3 ways we can represent probability. This is one of the ways at fraction. What's another way? Decimal, thank you. So you can also answer, 1 over 120. So you could also answer as 0.1 0.0083. What's another way you can answer? So we have a ratio, so there's ratio here, decimal, and there's one other way. Percentage, so how do I change that to a percent? Times by 100, so 0.83%. So there's three ways we can represent the probability. Actually, there's a fourth way, and the fourth way is odds in favor and against. Could show up as well. Okay. Commodity. Solve problems that involve the probability of mutually exclusive and non-mutually exclusive events. All right. For each of the following, state whether the two events are mutually exclusive or not mutually exclusive. So, selecting a prime number or selecting an odd number from a set of 15 balls, numbered 1 to 15. Are these mutually exclusive or not mutually exclusive? Does everyone remember what mutually exclusive is? Close, that's independent, dependent. So this one, mutually exclusive, nothing in common. Yeah, if they're mutually exclusive, they're excluding each other. They have nothing to do with it. There's no overlap. So mutually exclusive looks like two separate circles. Right? Not mutually exclusive would have an overlap. So let's go back to this first question. Mutually exclusive or not mutually exclusive? Are there odd numbers that are also prime? Yeah, so it's not, so some prime numbers are 2, 3, 5, and then odd numbers, 1, 3, 5, right? They have overlap, so therefore not mutually exclusive. Rolling a sum of 8 or a sum of 6? Can you roll both at the same time? No. Leah, can you put that on my desk, please? Your phone. Shouldn't be playing with it. Put it away. Okay. Sorry. Eating a peach or eating an apple? It's kind of a tough question. Can you eat both at the same time? Fruit salad. So I would say not mutually exclusive because you can eat both at the same time. Is there a peach apple? No, there's not. I'm thinking of it. They probably wouldn't give you that example. That would not probably be apple. Okay. Pearl is about to draw a card at random from a standard deck of 52. She draws a face or a spade, she wins a point. Draw a Venn diagram to represent the two events. Okay, so we have face cards, and we have spades. Okay, what are our face cards? Jack, queen, and king. So could we have a spade that's also a face? How many are there? 3. How many total face cards are there? 12. So how many face cards are not spades? Be 9. Total, how many spades are there? 13. So non-face cards would be 10. Okay, are they mutually exclusive? Nope. They'll describe. They'd have to describe it. So they usually don't use card questions unless they say they've done it before where they've said there are 52 cards in a deck. There are 13 spades. So they'll go through the whole description. Jack, Queen, King is a face card. Like they'll list everything. Yeah. Okay, what's the probability of drawing a face card or a spade? So I'm just going to go through some notation. Symbol for or. What was the symbol for or? The U, the union. So if we want a face or spades, the formula that we had before would be the probability that we draw a face plus the probability. So we draw a spade. Now, if we add those together, what do we have to take care of still, though? The overlap, we have to take it away. We've already added it an extra time. So minus the probability of a face and a spade. Good? Okay, so what's the probability of a face card? How many face cards are there? 12 out of 52. How many spades are there? 13 out of 52 minus how many faces that are also spades? 3 out of 52. Okay, that's going to give us a total of 12 plus 10, 22 out of 52, which if we add these up, that should add to 22 as well. Does that reduce? 11 over 26. Right? Okay. Moving on. I don't know how to say that word. A pinnacle? Is that what it says? Deck consists of 48 cards. 2 copies of the 9, 10, Jack, Queen, King, and Ace cards of all 4 suits in a standard deck. Let's skip this question. Let's move on. Okay. I eliminated from my copy, but I printed off the wrong one for you guys. So it's not here anyways. For each situation, classify the events as either independent or dependent. So what makes something independent versus dependent? So replacement, for example. So when the probability of the second is affected by the first, it's dependent. They're totally independent of each other. Okay, so 4 colored spinners spun and a dice is rolled. The first event is spinning red and the second is rolling a 2. Independent or dependent? Independent. Okay, a red die and a green die are rolled. The first event is rolling a 1 on the red. The second event is rolling a 5 on the green. What is it? Does the probability of rolling a 5, is that change if you roll a 1 on the red? No. 2 cards are drawn without being replaced. I can stop reading. Dependent. Yes. Okay. There are 30 cards numbered 1 to 30 in a box. 2 cards are drawn one at a time with replacement. Independent. Yeah. Okay. Parker has 8 identical black socks and 10 identical white socks. Loose in his drawer. He pulls out 2 socks at random. Determine the probability that he pulls out a pair of mismatched socks. That is 1 black and 1 white.
Oh, this is a quiz question. I did not like it.
Okay, socks. I like the socks question. Okay, so there's 2 ways we can do this. What are the 2 ways he can do it? Black, then white. What's the other way? White, then black. Okay. So we always assume when you're grabbing one, and then you grab the other. Like left hand, right hand. Okay? You can't choose the same hand or same sock twice. There isn't replacement, right? So what's the probability of doing black, then white? What's the probability of choosing a black? How many blacks? There's 8 out of 18. Now when we want to do something and then something, and is going to be addition or multiplication? Yeah, we could actually, it's multiplication. So if we're doing black and white, or is addition, and is multiplication. So times, so probability of A, B, and, so this is our formula. If I wanted to write my formula, the probability that we choose black times probability that we choose white, given that the first was black. Do you remember that? So that line means given that. Given that B occurred. Okay? So 8 over 18 times, how many white socks do we have? 10 over 17, because we've already taken a sock out. Which gives us 80 over, what, Dean? Calculator man. 18 times 17. Good. 136. So black then white, or white then black. Would the probability be the different or the same? It should be the same. We have 10 out of 18 for white first times. There are now still 8 out of 17, which still works out to be 80 over 136. So what do we do with these two probabilities? Add them because it's one or the other, or as addition. So 80 plus 80, 160. 306? I was going to say, that's greater than 1.
Huh?
Something's not right.
8 times 17. That's
18 times 17.
Well, you said 8. Sorry.
Sorry.
Take a pill, Dean.
It's all, I'm sorry. I will speak clearer. It's my, I tend to mumble. Math, enter, enter. So 80 over 153. Okay, so if the events are dependent, then our formula for A and B equals the probability of A times the probability of B, given that A has occurred. Yes. Oh, I reduced this fraction. So 80 over 306 plus 80 over 306. Right, we're going to add the two together. Sorry. Yeah. I don't know. I have no clue, honestly. I don't have a class block too when the blurb comes out, so I don't know. Okay, if they're independent, then probability of A and B occurring equals probability of A just times the probability of B. So those are our two situations. So we have to figure out, is it independent or dependent? The reason why you need to know your formulas is they can give you a theoretical question. We already talked about this yesterday. How, I'm just going to go to the very first slide. For a second, I'll go back. Given that A has occurred. So the difference is, this is dependent is used when, say, there's no replacement, whereas this is when replacement occurs. So the difference would be, say, in this formula, which is dependent. Instead of having 10 over 17, we'd have 10 over 18 here. The two are separate; they don't affect each other. Okay. A has occurred. Okay, so can I change slides for a sec? So we talked about your diploma exam, and this is on the third page. Okay, so we have 70% is multiple choice, 30% numerical response. Conceptual and procedural problem solving. So procedural is just rote math. Most of the time, well, rational expressions, you only can actually solve it by procedural. And there's already 8 questions, so that takes up most of the procedural. Meaning that every other unit is most likely going to fall either under conceptual or problem solving. Yay. Okay, so conceptual, what they might do is ask you a theoretical type situation where you need to know your formulas when it deals with set theory or probability. Yay. Okay. Relations and functions is logs. It's exponents, sinusoidal. It could be theory too. It could be problem solving or conceptual. Remember the earthquake problems in logs? That would be relations and functions. Okay, we're almost done. So let's look at example 9. Every day, Melissa's math teacher. Oh, I wish I did some of these problems. Oh well. Let her in this. Every day, Melissa's math teacher gives the class a warm-up question. It is a true-false question 30% of the time. Guys. And a multiple choice 70% of the time. Melissa gets 60% on true and false questions and 80% on multiple choice questions. Melissa answers today's questions correctly. What is the probability? It's a multiple choice question. Okay, so with these ones, whenever it's independent, because we want basically 2 things. What does my question say? I just want to see something. Or did I give this on the... Here it is. Do you have a lot more room or not that much room? Oh, that's too bad. Okay, the question should say, can I change this question? Yeah. What is the probability that Melissa answers correctly? Answers today's question correctly. Okay, so these independent problems, they work really good, especially ones with all this information if we use the chart. Do you remember the chart we made? So there's 2 situations. What are the 2 situations we have here? Multiple choice and numerical response. So here, there's a type of question. So there's a type of question, and then there's whether it's correct or false. Okay, so we have 2 types of questions, right? There's true or false, and then multiple choice. What's the probability that we have a true or false question? It's one of these ones. 30%? 30, and it's what's probability it's a multiple choice question? 70%. Okay. Now, whether she's correct or she's incorrect. So I can make this a little higher, maybe. Correct or incorrect. So if she's given a multiple choice, or sorry, true or false question, what's the probability that she's correct? 60% of the time? So what percent of the time would she not be correct? 40% of the time. Okay, if it's a multiple choice, what's the probability that she's correct? 80. So what would be the probability that she gets it wrong? 20. Now the question asks, what is the probability that Melissa answers today's question correctly? So there's 2 routes she can take. What are the 2 routes? So true and false correct. So this route, or multiple choice correct. So if we want to choose true and false and for her to get it correct, how do we get that probability? What do we do with those numbers? Multiply them together. So I'm going to make them a decimal. So this would be 0.3 times 0.6, which is 0.18. This one would be 0.7 times 0.8, which is 0.56. So how do we get it? What's percent will get it correct? What do we do with these answers? We add them together, which gives you 8 plus 6 is 14. Carry the 1, 5, 6, 7. So 74% chance that she'll get today's question correct. So these are independent type questions. You could also just solve it by breaking it up. So this would have been procedural. Yeah. Okay. Tanya estimates that her probability of passing French is 0.7 and her probability of passing chemistry is 0.6. Determine the probability that Tanya will pass both French and chemistry. So again, this one you could make the same chart. Okay. You could go ahead and set it up into French and chemistry, pass, fail. The other option is you can actually just work it out yourself. What's the if she wants to pass both French and chemistry, what's the probability she passes French? 70%. What's the probability she passes chem? 60%. So we could, instead of making the chart, you can actually just go straight to multiplication. 7 times 6 is 42. So 42%. Okay, what's the probability that she passes French? 70. What's the probability she fails chemistry? 40. If your probability of passing is 60, 40% chance of failing. So that would give you 7 times 4 is 28. 28%. Okay, fail both French and chemistry. What's the probability of failing French? 30 times 40% failing chemistry, so 12% chance, all right? All right, so I'm not sure how much time we have left. So at this point is technically when you would start working on the practice section. So you can start now.